panelists are joining us. I want to welcome you. I'm very, very excited to be here for this breakthrough session, and with an emphasis on the Midwest and Chicago and mHUB, what we're offering for breakthroughs that impact the state and the nation. So let's go down the row and ask for some introductions, and we'll start at the opposite end. Caleb, we're like bookends from the University of Illinois.
Hello. I'm Caleb Brooks. I'm an associate professor at the University of Illinois in the nuclear engineering department. Would you like me to share a little bit about what I do as well? Or are we going to come back through?
Got a minute, go for it.
So my research group studies advanced nuclear reactor systems. So small systems in particular, the microreactors and small modular reactors that have been coming on the scene over the last 10 years or so. So my group focuses on the design of those systems, but then also the opportunities in which they enable. And that's very large in the sense that we need to change the paradigms around licensing, around construction, around operations. So my research group focuses on those challenges.
Thank you. Siho?
Yeah, so good afternoon. My name is Sihong Wang. I'm currently assistant professor in the School of Molecular Engineering at the University of Chicago. It's really great to be here and have all the interactions. I really look forward to the rest of the afternoon. So in terms of research and technology development, my group is working on developing new generation of electronics technology to better interface with our human body as both wearable devices to especially be able to collect more types of information and do different things that are currently impossible for the current wearables, and also implantable devices. So we start from the basic materials level to try to completely radically change the property and the form of the current electronics to make them like stretchable as much as our skin, adhesive to the tissue, to the skin, as similar to a tape, and also like have the compatible property with the immune system with very less foreign body response, immune reactions. So we start from like a development of semiconductors to the applications.
Jen?
Well, that's hard to follow. I'm Jennifer Hinchy. I am CEO and founder of Fertility Science, which is fertile but spelled with a PhD out of spite because they told me I was infertile. And we are the first FDA-cleared and sterile at-home insemination kit that conceived my daughter, who is now 6. Thank you. She's pretty cute. She's in kindergarten right now, hopefully. And yeah, I also come from, I got my PhD at Northern, and my background is in bioinformatics, so computer science and biology.
And for those of you who can't see Jen's name tag, it doesn't say panelist, it says finalist. So Shannon alluded to, we have a hat trick on the stage. She's also up for the Rising Star Award and Innovator of the Year. So Jen, good luck today.
Thank you.
Jan.
Thank you.
That is very hard to follow, for sure. Welcome, everyone, and thank you so much for coming. And I'm Jan Chow at Northwestern University, and I have been associated with the mHUB since its inception. Currently, I'm on the board, so really impressed with mHUB's team's achievement and being very proud of a member of the mHUB family. So welcome all of you here. My own research at Northwestern is we are known for our flexible manufacturing processes and the ability to predict, sense, and control the flexible processes through our computational and AI methods. Specifically, the processes we have been working on and known for is robotic forming and metal 3D printing. I'm also Associate VP for Research, which I help with my colleagues, both inside and outside of Northwestern, to help establish a great ecosystems for everyone here, pushing the technology forward. Yeah.
Well, thank you, and I'm really, really grateful to be on stage with such accomplished innovators. We all know there's a lot of uncertainty and chaos around the nation, but the Midwest is just a magnet, I think, and a hub for innovation and science. So I'd like to ask each of our panelists to think about our true north. What is it, maybe one sentence or one word if you can do it, that makes the Midwest such a hub? And let's start with Jan.
I would do more than one word. So what I think this is really good here, we have really infused with minds, the great minds fused by our great universities and national labs in the region, as well as the hands. We are the doers in Midwest, right? We make stuff. And I think the third one is really important is the network, being the hub of the transportation, traditionally. Now the mHUB right here with the networks with, the founders, the sponsors, the manufacturers. This is the hardcore of our, the strength in the region.
Jen.
I think that there is a lot to be said about our Midwestern charm. I think that we tend to want to collaborate and network really well and help each other. I know from growing up on a farm, like the farming community is very close-knit, and like you said, we're doers, and I think that really shines here in the Midwest.
Great. Siho?
Yeah, it's certainly too many things that's coming to my mind. If I try to use one word, I think that would be ecosystem. So yeah, I think if you think from the technology development aspect from the very beginning, like the first idea in research labs, all the way to the commercialization, to the application of the technology, you really cannot find there's nothing you cannot find in Midwest, like for what we do, from all the great universities, national lab, and also the very good medical systems, the investors, and the leading like a Fortune 500 industry companies. So that's really builds very strong atmosphere and the platform for the technology.
Your sweeper, Caleb.
Well, I would say accessibility. I think financially, the Midwest is very accessible in terms of resources. Certainly within my sector, land and water resources are very important. In education, not just the strong higher ed, but also the trade schools and the broader access to workforce is really critical and I think is well represented in the Midwest.
Thank you. Well, now let me go to Jen. You've had a remarkable 2024 year. Approval from the FDA, and then your product hits Amazon, and I saw you can get it in one day. You can get it overnight, right?
My mom is shipping them right now.
Yes. that's
my
the
mom
community.
if you order from Amazon.
That's the community. And then you made the inventors list on time. So what a great year. So I wanted to ask you, how do you ensure that these innovations remain sustainable and accessible for societal benefit?
I think it's about putting people over profit. I lived in fertility. It's not pretty. And the reason I started this company is I knew, as a PhD in biology who happened to be married to an engineer, we invented our own device that conceived our daughter. Not everyone is as nerdy as us that wants to go around and do that. But I now have held another baby that is here because of Fertile, and that's never lost on me, and the ability to put people first and really challenge the system. I don't think that I needed $10,000 worth of fertility treatment for unexplained infertility, and I didn't know what was wrong. And so when we start asking those questions and start asking why and putting people first, I think good things will come.
Great. And Sihong, your research is human-oriented, right? Wearables, people over products. Can you talk about how that you'll impact that with that philosophy?
Yeah, certainly I fully agree with that. Yeah, so, for us, it's always, humans need come first, right? That's how we find the problems that we want to tackle. It's basically by looking at, like, for example, from healthcare, health monitoring aspect, what are the needs that still cannot be fulfilled by the current technology? And then to try to go down as a scientist to analyze where is the fundamental limitation that we need to overcome to be able to enable a completely different path to address the currently unmet needs. So yeah, I fully agree. This is probably the best approach.
Is there any of the wearable data that we wouldn't want out there, or when you're thinking about that?
You mean we wouldn't want?
Yes, yes.
Well, as you know, I think if we can make a good use of the data and keep all the data in good personal privacy, all the data could be useful in some way.
Great.
That's my thinking. Yeah.
Great. Well, public perception is really important for society benefit. And Caleb, you've got nuclear. How do you think about public perception, and how do you move the needle on that?
Yeah, in nuclear engineering, I really see all roads go through public perception. There's countless comics out there that have done some variation of that joke where you solve the energy crisis, but someone hears that it's nuclear and they want to run away from it. And so what we've seen over the last 10 years is as we move towards smaller nuclear systems, it's really being done with this in mind. There are other reasons, there's economic reasons and safety reasons of why going smaller is a huge benefit, but a lot of those are meant to translate to public perception and making nuclear more palatable. And in particular, as we go with smaller systems, we need to look towards new markets, so less about just feeding the grid with electrons and more about co-location with energy-intensive processes like data centers and advanced manufacturing and those sorts of sectors. And in that case, we need very safe, reliable devices that can be sited not behind miles of fencing, but right there where the energy is needed. So that's really been part of the design philosophy in the next generation of nuclear reactor systems, is to be able to be marketable to the American public and to the public around the world to convince them that nuclear can be safe.
And the Midwest, have you found that it's been more helpful to be in the Midwest here when you think about public perception in Chicago and our rural communities?
Absolutely. So at the University of Illinois, we have a project where we are currently in the licensing process to demonstrate a new advanced reactor on our campus. And through that project, many opportunities to engage with the public. And we are seeing a lot of acceptance for these small nuclear reactor technologies. And I think part of that comes from the Midwest history around nuclear power. So the first sustained man-made fission reaction was here in the city, right, at the University of Chicago. And then from there, a long history of development of advanced reactors, both at the national labs, like here at Argonne in the city, and then also at universities all over the country. And Illinois being the largest nuclear power generator of any state in the country, I think there's a lot of positive literacy around nuclear that I've found in the state. And so there's a lot of benefits, certainly, to our project in having that general public knowledge around nuclear power.
Thank you. Jan, you think a lot about the supply chain and additive manufacturing and manufacturing in general. So what are the biggest hurdles in translating cutting-edge research to doing this right here in the Midwest?
I would say that, as everyone knows, the manufacturing these days, the supply chain is a big issue. So the challenge doesn't just apply to Midwest, it actually applies to many of the rest of the country. And one thing with for example, I'm in the area of, started with the metal forming, right? So the place that where we make the car, so you have Ford plant right here in the southern half of Illinois and in Michigan, Midwest. But many of those toolings are not made here in the States, So when you think about things, the casting, because originally was viewed as kind of dirty and not so good investment, and they become overseas and then come back, and therefore, without the tooling, you can't make those parts, right? So the supply chain is quite complicated in that sense. Therefore, some of the work that we have been doing is how do we create flexible manufacturing processes such that you don't have to rely on those very long supply chain. So 3D printing is one of the way, metal additive. Another way that we are working on is the robot forming, to use the flexibility that robot can bring to us and to make the parts directly, rather than have this huge, tool and die, which could be take about 15 weeks to do it, right? Now we can narrow it down to use the digitization, and then you can finish it within a week. So, yeah. So anybody, I think Haven asked the question, how many manufacturers are here, right? As a designer, product designer, when you try to particularly do the scale up, I think it's really beneficial if you talk to the manufacturer earlier so that you know the product you designed could be scaled, and that will shorten your development cycle tremendously. So I think the mHUB provide this kind of connection is very critical to solve this, address this kind of supply chain issue.
So are your products that you're trying to make, are those subjected to the supply chain, and how do you think about that?
Yeah, so yeah, everything we are working on is towards turning those into products. So yeah, certainly the supply chain is very important. So even for the current stage of developing those in the lab, like in their early stage, we also rely on the supply chain, right? Like, from the COVID time, we have been feeling if, like some of the materials or special tools we need for research can also arrive on time. That will delay even just the research experiments, but imagining if it's becoming a continuous production line, then all the materials, like usually for one type of device, we need a different kind of materials, and also the manufacturing, like components, that's all coming together. So any one of these missing will be a big problem. We could completely stall the process.
And Jen, you raised your hand as a manufacturer.
I never thought I would ever do that. I didn't set out to be a manufacturer, but everything you said is spot on. We manufacture completely right here in the Midwest, and in order to do that, I had a steep learning curve, I will say, as a scientist, then to making a product. And again, thankful that I married an engineer that had that experience, but there has been a lot going into from making the first prototype to now being available on Amazon and being able to scale a product without any disruptions to those supply chains in an efficient, cost-effective way too.
Tariffs. Tariffs are coming down the line, or they're here. How do you deal with that, Jen? Can you solve that problem for us?
If I do, that won't be here probably. Yeah, tariff, so a couple of years ago, I think I wrote an article in the op-ed. Basically, what I think U.S. is focusing on own manufacturability, and a lot of this is investment also in the hard machinery areas. But as I mentioned, because these are the fundamentals in order to get your next die, next tool, next parts made. And therefore, and Midwest is, a heart of that, right? Therefore, I think developing our own capability is, requires really a lot of, partnership between public, private, and consortium type of the partnership. So how many of you know MXD also? Yeah, quite a few. So MXD is one of those manufacturing institutes that the government funded. It's actually here in Chicago. The goal of that is to create this partnership between federal government and the local economy. And I think we need to take advantage of that. And for every citizen here, I will also say that write to your senators, write to your congressmen, because that makes a difference, right? They are the ones, hopefully still, making these budget allocations. Yeah.
That's right. So manufacturing, obviously if we want to grow manufacturing in Illinois, we need energy. We also need energy for data centers. Can you, Caleb, talk about the data energy nexus and where we're headed? Are we going to be able to accommodate that?
Yeah, that's a great question. And I think to put it in perspective, it's been really decades in the US of our energy demand not really increasing, our net energy demand. So we went, several decades, really any energy demand increase was kind of offset by efficiency improvements. And then just recently, now we have a huge growth, as projected as much as 10% growth in our electricity demand, which is substantial for a sector that more or less was just humming along at a baseline. And so where we see data centers, maybe even some new manufacturing sectors, and then maybe electrification really driving those, but data centers in particular. And with the DeepSeek and that in this, earlier this year, which caused some kind of ripples around what sort of data needs would be required for large language models. I actually think the advancements that have been made in large language models will make it even more accessible, which will actually increase the demand for electricity in that area. But maybe it'll democratize it a bit. You don't need to have these huge giga scale type of electricity plants to run your large language model training. But perhaps you can have a lot more smaller, you can have more players in the game. And if we start to move towards new aspects of large language models or machine learning towards video and things, then you have latency issues, and you really want to have that capability close to its demand. And so there you start to think about, well, then where are you going to get the electricity? Where are you going to get the energy demand for that? And then any computer resource not only does it need energy, the electricity, but it also needs a cooling. So nuclear reactor systems, I think, are really well positioned to mate well with the data center need because of the scalability that is now inherent, I think, in the new design of reactor systems, and maybe even more importantly, the kind of silo ability or the island ability of these systems to not have to interface so much with the grid. So that's where I see advanced reactors, particularly small modular and micro reactors, playing a big role in the data needs to come.
And the race to Mars, that might help with the race to Mars, right?
Yeah, NASA also has a lot of programs right now around space fission systems, both surface power for Moon and Mars, and then also propulsion.
Well, I've spent a little bit of time in Washington the last few weeks, on and off, in concert with my fellow senior research officers from other universities and on the Hills. And what I continuously hear, what will be strong as far as the research agenda with this administration, is quantum. I think we're checking that off. And you'll hear more about that later with the Illinois Quantum and Microelectronics Park at a later session. HPC, high performance computing, AI, and also nuclear is creeping in there in a big way. So I want to think about AI and ask the panel how your areas might benefit or intertwine with AI. How are you seizing the moment on this? Don't be shy.
I first started machine learning during my doctorate while I was at Argonne. So for my dissertation, we were using machine learning. That Argonne computer was, I don't know, more than most people's houses. And we have come a long way since that. But AI is helping us move this technology so much more quickly. For example, even though we have a fertility product, one thing we are utilizing AI for is to be able to really help our customers understand when to use our product. It's not enough just to have it. You have to know when you're most fertile. And so we are building AI models that will be what we're calling conception concierge, so that will help people feel supported and have a lot of the educational resources that they need, and we can answer them in a very personalized way.
So the data that you're getting, where is that coming from?
From the people, yeah. So they will be providing it, and in our case, we don't have to deal with like the HIPAA laws necessarily because we're over the counter. So all of that data from our customers gets aggregated to make it better for the next customer.
And people helping people.
Yep.
Do you want to talk about how those, before we go back to AI, how did those people help you get through the FDA? You told us a great story earlier.
Oh, with the people the crowdfunding?
Yes.
Oh, that story. Okay. Yeah,
Many stories.
people helping people. I said that when I met with the FDA, they said, okay, you're going to need clearance. And I'm just in my ignorant bliss, not knowing what that costs. And then I learned it to be 3 to 5 million, which I did not have laying around, surprisingly. So I decided to try crowdfunding, and it felt like I was running down the street naked telling everyone that I couldn't have children. And instead of them laughing and making fun of me, they were like, okay, this is what we're doing. And 400 people that were going through the same thing invested in Fertile. We raised $630,000, which paid for FDA clearance. And so people helping people is tremendously powerful.
Did I mention something about a hat trick earlier? Jan, I read your website, and I got to bring up the Japanese sword. You may want to deviate from that, but Japanese sword making and AI was something that you mentioned.
So yeah, well, you know the metal forming pieces. So one of the things with manufacturing is we have a lot of data, but nevertheless, the data is also something people start to keep within themselves, right? Because it's an advantage to its competitiveness, But nevertheless, say if your neighborhood, if you could share the data, then actually everyone is going to get benefited. So talking about Japanese, the Japanese society is actually very collaborative. Sometimes they share those data within their own, Japanese companies. And then that helped to raise the bar, right? Same thing, Germany is doing this, China is doing this. So one of the dreams that we have here is actually, we had this National Academy study on smart manufacturing, which was published in December of the last year, is to build up this data bank. We won't call it a data base, because if you think about the data bank model, it's a new model, right? You can put in your data in, but you can get benefit out of this. So if we can collectively build up this data bank that help, that would be great. So one of the things, also with the manufacturing processes is that you have so many design freedoms, right? So one of the way to generate data, certainly you can go to the shop and do it. But another way of generating the data is through numerical simulations. So with the AI, what's helping us is to how do we speed up the computational time? So previously, it probably take a month. Now we can do it under 30 seconds. So with that, but still with the right physics in there, this is where the university is really good at this. And then we can generate quite a lot of data, try different passes, and we can put into this data bank and help to design the forming processes to make the Japanese source, and you can even start with the additive manufacturing as the raw billet, and then you can go further forming to get to the property that you want. So if you think about linking all these different manufacturing processes together, what I would say AI helps is to help you speed up the physics-based simulation, help you to use that to the design. So there's a lot of design looking at the variations, as well as help you control the process. This is similar as what you said, when to do it, right? So when do you need to maintain your press? When do you have to go put some additional sensors in? So all these things AI could help, but eventually what's really going to help us if we can create this data bank, create the data highways, and benefit everyone. So this is get small businesses connected. That's my dream.
Oh, that's a great dream. Can we talk about the data bank for a minute? Sure. Who owns the bank? And as a customer to bank, how do you get that trust so people will deposit their data?
Right. So we had some thought about this. One of the things is also you need to have certain data structure. And we were thinking the National Institute for Standards, that could be a very good one. They are, lots of us, have to conform to those standards. They could be the very good ones to help to set this thing up. And then the ownership, that is, I think a creative mind here probably can help me to think about who owns it and what would be the way to kind of monitor that. Yeah.
It's like a credit union. NatCast set up a sort of a credit union like where members join, right?
That's a great idea, yeah.
Well,
So maybe we should patent that
we
here.
should, in Chicago, in the Midwest,
Right.
In front of all these witnesses.
Yes.
Caleb, tell us about AI. How is that going to impact or help nuclear?
Yeah, so I mean, there's a joke that we need our high-performance computing. We need nuclear reactors to power our high-performance computing to run simulations to demonstrate that we can operate reactors safely. So it's kind of a circular loop. But in reality, if we can make these systems small and safer, really the holy grail of nuclear is to make a reactor system that the operations isn't about safety anymore. Now it's just about asset protection and delivering your product the way that it's supposed to be delivered. And if we can get there, then we can envision a lot of opportunities around AI, around normal industrial processes like improved preventative maintenance strategies and fault detection. In nuclear, we have very large quality assurance requirements. NQA1 is one of the most strict quality assurance standards there are. And in that case, that really just means a lot of paperwork, but then also quite a bit of data associated with critical systems. And so the ways in which we can leverage that kind of nonlinear mapping of machine learning to better understand where failures are coming from and those sorts of aspects, I think can drive us towards a more efficiently operated system, which will be required as we go smaller, right? Because as we go smaller in our nuclear system, we're not about putting electrons on the grid anymore, right? So it's not, success isn't measured in 10 reactors, it's measured in thousands of reactors, right? And in that system, we de-risk the CapEx, the capital cost portion and the construction portion, but the risk shifts towards the operations and maintenance. If you're 200 times smaller, can you operate it with 200 times less people? I don't know. And that's what we need to address in these new systems. So AI can potentially help with a lot of the operations aspects of new advanced reactors.
Thank you. Siho, I can only imagine how much data you're pulling out of those wearables. It's got to be incredible. And then you multiply that by the number of people wearing the wearables. How do you think about AI and managing that data?
Yeah, so that's something we have been thinking about and working on every day in our research. So indeed, you ask a question about is there any kind of information we don't want to extract from wearables? So I would say probably the thing we don't want is too much information, especially beyond the capability of that the AI can analyze or consume too much power. So then how to use the more personalized design of the electronics and also managing its operation, its function from the AI to make it more efficient, only collecting just enough data for analyzing and extracting the health information is definitely something very important. And another really important thing that we are also working on is whenever talking about the health data, the privacy, the safety, data safety is one of the most important topics. Right now, the implementation, the use of AI largely relies on the data center. So basically, when we use the large language model, ChatGPT, we are uploading the information online. But for regular data, that's fine. But if it's our very private health data, we probably don't want to do that. And a lot of current wearable devices is already working towards having the AI analysis just happening within the device so that you don't need to put your data constantly online. But to really get to the level that's on-device implemented AI can analyze the thing we needed, it needs higher efficiency. So that's what we are working towards by incorporating and developing a new generation, a new paradigm of computing. It's called neuromorphic computing. It's from the concept of biology and our human brain is working much more energy efficiently compared to the current computing technology. So we consume like orders of magnitude less power. Then if we can understand and emulate how the neurons in the brain, the nervous system is working to design the new kind of a computing hardware, then it will not only be much faster, but also become much energy efficient. So then if, continuing this technology direction and turn it into the human compatible form factor to incorporate it into the wearable devices so that the AI analysis can happen at much more powerful but much less energy consumption demanding scale, then we can realize the possible future that the wearable devices is on one hand, collecting more data and also continuously, but also on the other hand, all the data can be analyzed by AI, and then even without passing through the human user, already immediately decide what to do from the other end, like the control or the therapeutic functions.
So thank you for that. One of the assets that I'm most proud about and that we landed in the state of Illinois in Chicago is the Chancellor biohub, the second one in the nation, bringing an enormous investment. And that was the product of our universities really working together across interdisciplinary boundaries. And the goal of that is to measure human biology. And Siho, that's right up your alley. Can you talk about that asset and how it's benefited your work?
Yeah, so maybe let me ask how many of you have heard about the Chancellor biohub? Okay, yeah, there are quite a few. Great. So just first some background knowledge. It is coming from the Chan Zuckerberg initiative, right? From the Mark Zuckerberg, and then funding the technology developments for studying biology and help the human health like a medicine. So Chicago got the second one across the entire nation, and the key focus is to develop new type of tools for studying biology, and particularly for our focus here in Chicago is to study inflammation. Inflammation is a very important part of the health, including autoinflammatory diseases and also inflammation from different kind of infections. So the biggest value I see from like the establishment of the biohub is a kind of correlates to the word that I was talking about for the Midwest, like advantage. It's an ecosystem. It's enhancing the entire biotechnology, bioengineering, research and the technology ecosystem here in around the Chicago area. So it's a partnering with the 3 universities, UIUC, Northwestern, and the University of Chicago. And also at the same time, they are building their own research entity, their own research lab, research groups. So it's really creating a tremendous like a research community, bridging together the engineer, the physical scientists, biological scientists, and the health and the medical doctors to work on a common set of problems, and also coupled with the establishment of the very cutting-edge research facility. So I think it will generate really the great things at the full frontier, just right here in the Chicago area.
Thank you so much. We have about 3 minutes left, so I'm going to ask you, there's a lot of young professionals in the room, students, young entrepreneurs just starting out. Piece of advice in less than a minute from each of you, how they go on to break the boundaries that each of you are breaking. I'll start with Caleb.
I think it's a great time to be in tech, to be in science, to be in engineering, or to be surrounding that community. I think we're at a point where we can see huge growth across all those areas. So be ambitious. I think that's shared on the panel here, and yeah, go after it. Do something that you love, and there's lots of opportunities out there to go out and get it.
Siho, what will you add?
Yeah, I would say, with the very fast developments of world and technology, it's important, very useful to keep the eye open on many different things and really, pay close attention to where the world is going, is evolving, and then based on that to find where the problem still exists and the big opportunities will be coming up in the next 10, 20 years.
Jen.
I I'm a big believer in doing it scared. I think that there's a lot of people that have a lot of really good ideas that, you know, are too scared sometimes to tell the world they're infertile and want to go off. And it takes a lot of courage to do that, but I think I would just encourage all of you to try to do it scared. And once you've helped someone else and you've felt the joy that can spark inside you, then chase after it as fast as you can.
Thank you. Jen?
I would say don't be shy of sharing your idea with the others, because sometimes through the integration, by talking to many other people, you can help to refine the idea. So often you think, oh, this is my idea, I want to keep it secret, and I want to develop, and then once it's ready, then we'll open it up. This might be already too late, or doesn't fit the customer needs. So we use a network, talking to people, and help to build up the further the idea. I will encourage that.
Thanks, and I think also I will add, there's enormous assets in this community. We're sitting in this amazing facility, mHUB. Thank you, Haven, wherever you are out there for leading this transformation. Talked about the Chan Zuckerberg BioHub. We have the Illinois Quantum and Microelectronics Park, Chicago Quantum Exchange. We have an NSF engine. We have MXD, Chan Zuckerberg BioHub. There's just so many assets, and I guess my advice would be there's people out there to help. There's people out there that have been very successful. They want to help you. Someone mentioned this is a community of trust and collaboration, and I think we're second to none in the nation. I want to ask you to just take a moment to thank our amazing panelists. And
Thank you, Susan.
Thank you.